What's up, my people? In this video, we're going to be making a video about exponent laws and log laws and solving for these. Let's get right to it. And just in case you hear me sniffling, these allergies have been going crazy today. So, hey, we'll work with it. All right, so let's do a quick review on the law of exponents, some of the laws that we had the other day. So remember that the first law is if I have log to the x times y, that's equivalent to log x plus the log of y. That's our first one. The other one was log x divided by y is equivalent to log of x minus the log of y. Then we had another one that said the log of, let's say, a number to a number, that equals 1. And then remember when we did our swoosh thing, our swoosh method, log of a, b equals c. When we would swoosh that, the exponent formula, or the exponential rule, or the however you want to look at it, is going to be a to the c equals b. Okay, we're going to use these 1, 2, 3, 4 in our stuff today. So let's get right into the equations. And once we get to the very end, excuse me, once you get to the very end, you're going to have a total of 12 questions you're going to do on your own, and you're going to answer them in the Ed puzzle. And we're going to be doing, you'll have questions throughout this Ed puzzle. I'm going to do 12 examples. I'm going to be moving kind of quick. If you need to stop or rewind, go ahead and do that. All right, so the very first one, I have, this is number 1. I have 12 examples I'm going to do. 3 to the negative 2p equals 3 to the negative 3p minus 2. If my bases are the same, that means my exponents have to also be the same, which means I need to set them equal to each other. So I have negative 2p is going to be equal to negative 3p minus 2. I got to solve this. This is an algebra 1. I'm going to add 3p to both sides. 2p, negative 2p plus 3p is just a regular p, and equals negative 2. Okay? That is the answer to the first one. Not too bad. All right, let's move to question number 2. Number 2 says, what if I have 64 to the b equals 16 to the 2b? And in our example right above, we couldn't do nothing with the exponents until we have the same base. So what we're going to need to do is change these numbers, 16 and 64, to where they have the same base, okay? 64 is equivalent to 4 cubed. And 16 is equivalent to 4 squared. They both have the same base now. But we can't forget that we started with the b, and we started right here with 2b. We got to multiply those, okay? So now that our bases are the same, I can set my exponents equal to each other. And that's going to be 3b is going to be equal to 2 times 2b is 4b. I'm going to subtract 3b from both sides. 4b minus 3b is just b equals 0. Yes, sometimes your answer will equal 0. Okay, so that's that one. And let's use this side. Let's do number 3 on this side. Number 3 says 27 to the negative k equals 1/3. I got to figure out how I can get the same base, and 27 happens to be 3 cubed. Okay? And don't forget, I have this k already up here. That stays there. And then remember, if I want this 3 off of the bottom and I move it to the top, that means what happens? That means this could be 3, and this is now -1. When it moves to the bottom or the top, it changes signs. If it's the same number, you just leave it. So let's go ahead and make a note for that. When moving from the bottom to the top, you will use a negative exponent. You will use that rule today. Okay? So now that both of these are the same, that means I can set this one equal to that one. Okay? So let's go back. So I got -3k equals -1. I'm going to divide both sides by -3 so I can get k by itself. And my k is going to be equal to a positive 1/3. Okay? Nothing too crazy. All right, let's keep moving. Let's do number 4. So we're moving right through these. Number 4. Number 4 says 16 to the 3r equals 8 to the 3 minus 2r. I can't do nothing with them until their bases are the same. So, yeah, let's go ahead. Let's use 2 this time. Because sometimes you'll see that you could, yeah, let's use 2. All right, so 16 happens to be 2 to the 4th power. And 8 happens to be 2 cubed. And with that being said, remember we have this 3r already up here. And up here, we already have this 3 minus 2r. Now that these are the same, I can set those two equal to each other. 4 times 3r is 12r. Then I got to distribute that. 3 times 3 is 9. And that's -6r. Okay, I'm going to add 6r to both sides. And this ends up becoming 18r equals 9. Divide both sides by 18. And when we reduce, r is equal to 1/2. Okay? That is the first 4. We got 2 more like this. We're going to jump into some of the log ones. And then we're going to scroll down and allow you to do some of the others. All right, let's do number 5. This is number 5. Number 5 says 9 to the v equals 243 raised to the 3v plus 3. Ooh. I got to figure out what times what does what and all this other good stuff. Well, I do happen to know that 9 is 3 squared. And 243 is 3 to the 5th power. Don't forget I already had a v up here. And don't forget I already had this 3v plus 3 over here. Set these equal to each other. 2v is going to be equal to 15v plus 15. And then what do you think happens after that? I'm going to subtract 15v from both sides. That's going to be negative 13v equals positive 15. I'm going to divide both sides by negative 13. So v is equal to negative 15 over 13. Okay. I'm going to do one more of these type. But I want you to pause the video right now. Well, after I write the question down. I want you to pause the video right now and tell me what you think the answer is. Go ahead and pause it right now. All right, now that you've had the time to attempt to do this one, let's see if we got the same answer. 49 happens to be 7 squared. And 343 happens to be 7 cubed. And don't forget I got this 3x here. So in other words, it's going to be 6x. It's going to be equal to 3. Divide both sides by 6. X equals 1/2. Hopefully, you got that. X equals 1/2. All right. So that is how you do the exponential ones. Now let's go ahead and jump into some of the questions where we have to expand and do some other things. All right. So before we move on, I'm going to point something out. Anytime you have log, base any number, and this number right here, this b, that b right there can never be negative. If you ever end up with an answer and it makes one or two of these where that b is at negative, that results in a no solution. Okay? So let's jump right in. All right, so this is number 7. So I have log 7 to the x plus log 7 to the x plus 3 equals log 7 to the 10. All right, so remember these rules at the top. In order to get that plus sign in the middle, that means we had to have started with multiplication. So that means that we had to have started with log of 7, and then we must have did x times, and then we had x plus 3 equaled log 7 to the 10. Okay? Now that we have that, now remember, if these are the same, that means that these have to be equal or the same. So x times x plus 3 needs to equal 10. Well, I need to distribute this. X squared plus 3x equals 10. And when I see this, I know I got to make this equal to 0. And I got x squared plus 3x minus 10 equals 0. And we're back to our favorite thing in the whole wide world, factoring. I know you love factoring. So I'm going to put 3 here, negative 10 here. And then when I put 7 minus 3 like that, 7 times, I am kidding. It's not 7 and 3. What in the world am I talking about? Lord have mercy. All right. So I got to figure what times what makes 10, not 21. I don't know where I got that number from. All right. It's going to be 5 and negative 2. 5 times negative 2 is negative 10. 5 minus 2 is 3. So I'm going to put these. That positive 5 goes there. That negative 2 goes there. And when I set these equal to 0, minus 5 minus 5, I got x is equal to the negative 5. And then when I set this one equal to 0, x equals positive 2. Right, so far so good. All right, now, there's a problem though. This one cannot be an answer. That negative 5 cannot be an answer. Why? Because when I go back to the original up here, I should be able to put that answer into either one of those and it should still end up positive. If I put a negative 5 right here, that makes this whole thing negative. That doesn't work. Also, if I put a negative 5 right here, this total is negative 2. That wouldn't work for that one either. The only one that works for this is the positive 2. So this one only has one answer. Okay? So after you get your two answers, always take a look back and see if it makes that negative or not. And if it does, it's that part. This one would not be a solution. This that positive 2 is the only correct solution. Number 8. This says log 4 to the 2 plus log 4 to the 3x equals log 4 to the 60. All right, so if there's a plus sign, that means that we started out as multiplication. So this is log 4 to the 2 times 3x equals log 4 to the 60. And because these are the same, I can set this one equal to that one. So in other words, 2 times 3x is going to be 6x equals 60 divided by 6 divided by 6. X equals 10. I'm going to take a quick look and make sure everywhere there's an X, I can plug it in. It doesn't end up negative. When I look here, well, there's a number there. I can't plug a 10 in there. There's nothing to do. Well, if I plug a 10 in right here, that makes that positive 30. So this one is good to go. Okay, that was number 8. Moving right along. And I'm trying to make sure I cover like all the different examples that you're going to run into in just a few moments. This is number 9. Number 9 says log of 3 to the 8 plus log of 3 to the 2x equals 4. Oh, it doesn't have a log at the end this time. So that means something here is slightly different, but the rules didn't change. Okay, so this ends up becoming, because there's a plus sign, this ends up becoming log to the 3. And then this is 8 times 2x equals 4. Huh. This ends up becoming log 3 to the 16x equals 4. I wonder if we have any rules that can help us out with this. And we do have one. Remember the one called the swoosh. Oops, sorry. And so when we swoosh that, we end up with 3 to the 4th power equals 16x. 3 to the 4th power happens to be 81. Divide both sides by 16. And x is going to be equal to 81 over 16. You can try to reduce that, but you can't. Okay, that's number 9. All right. Now let's get into like one or two of the somewhat challenging ones. Not too bad, but got three more left. Number 10. Number 10 says log 4 to the x minus log 4 to the x plus 6 equal log 4 to the 21. Ooh, that's no good. That's a lot of stuff going on. But when there's a minus sign, what does that mean happened? It means division happened. So that means this had to have started out like this. Log 4 to the 21. If these are the same, I mean, you should have it by now. This should equal this. And we got to cross multiply to get these fractions off. So 21 times x plus 6 is going to be equal to x. That makes this 21x. And then 21 times 6 is 126 equals x. I'm going to subtract 21 from both sides, 21x. I got 126 is equal to negative 20x. Divide both sides by negative 20. That means my x is going to be negative 126 over 20. But I'm going to need to reduce that. But do I really? So my answer here happens to be negative. And remember, when I check my answer, I got to go check it back here and here. And alone, because it's a negative right here, if I plug that into that, that would make that whole thing negative. This happens to be no solution. Okay. Let's see something. Let me go ahead and add a page. Don't look at that yet. Don't look at that yet. So yeah, I'm just writing really big. Okay, here we go. Ta-da, just add some pages. That was number 10. Just got two more, and then you'll be on your way to try these on your own. This is number 11. All right, so now we got log of 7 to the x squared plus 5 minus log of 7 to the 2 equals 1. And this one we're going to do two ways. So this was a division problem. So this had to be, I'm going to write log 7 to the x squared plus 5 over 2 equaled 1. But remember, there's a rule that equaled 1 earlier today. And remember that rule was, I'm going to draw it off to the side. Log this to that equaled 1, but this had to be the same number. And since I'm already dealing with 7, let's change this to log of 7 to the 7. Anytime you have the base and the big number to itself, that equals 1. Now, since these are equal, I can go ahead and go x squared plus 5 over 2 equals 7, because this has to equal that. Now, let's go ahead and solve this like regular algebra. Multiply both sides by 2. And you end up with x squared plus 5 equals 14 minus 5 minus 5. x squared equals 9, square root, x squared. So not x squared, x, sorry. No, x squared. X equals positive or negative 3. And if I put a negative 3 up here, if I put a negative 3 right in there, negative 3 squared, positive 3 squared, they'll both end up positive at the end. So we're good with that. Okay, another option could be to do the swoosh, because this would have ended up with log 7 to the x squared plus 5 over 2 equals 1. And this is if I would have left this right here equal to 1. We would have swooshed this. So we would have had 7 to the 1, which is just 7, equals x squared plus 5 over 2. And this step right here is literally this step right here. It's the same exact steps. Because from there, I multiply both sides by 2. And the work is the same. Okay? But I'm not going to do that to save us some time. And then finally, number 12. Whew, I'm glad this is over, because these allergies are beating me up. All right, anyways, number 12. Finally, we got log base 9 to the x minus log base 9 to the x minus 3 equals 1. And for the purposes of this one, I'm just going ahead and do the swoosh method. So I'm going to do log of 9, and this ends up being x over x minus 3 equals 1. I'm going to go ahead and swoosh this around. So 9 to the 1 is just 9. So we really don't need to write that 1 there. And then I got to solve for x. So I got to put this over 1. Now I got to cross multiply. X equals 9 times x minus 3. 9x minus 27 equals x. I'm going to subtract 9x from both sides. And then x minus 9x is negative 8x equals negative 27. Divide both sides by negative 8. And x is equal to positive 27 over 8, because those negatives cancel each other out. All right, so now that we have gone through all of these wonderful examples, you're going to have to do 12 on your own, okay? So what you're going to do is you're going to do those first 10. So, and then you're going to end up doing these last 2, okay? So if I were you, I would pause the video now. The video is going to stop in a minute anyway. And go ahead and submit your answers in Edpost. And once that's done, you'll let the video finish playing out, and then that'll be it. All right, if you have any more questions, come see me in class. Have a good day.